Sweet. Hey, listen, please, listen. So I'm just going to state it. Look. It says the graph of a twice differentiable function f. Stop there. Okay, that means you have a function f. If you go to every point on f, you can find a tangent slope. You take all those tangent slopes, you plot them. That would be a graph of f prime. You do the same thing again. You go to every point on f prime, you find a tangent slope. You plot f double prime. Therefore, f is twice differentiable. So they're showing you a picture of f, and they're telling you on f, everywhere you can find a slope. On f prime, everywhere you can also find a slope. That's what they're saying. So, and because in order for a function to be differentiable, the function must also be continuous, you've also learned that f prime and f double prime are all continuous. So that's what they're telling you. Is everybody okay to this point in the problem? Okay, after that, we're just supposed to figure out which is true. So your eye should be focused only on one point, right there. And you just go to work. F of 1 is 0. F prime of 1, I use Daniker's chart. At this point on f is increasing. Therefore, the y-coordinate of f prime at x equal 1 will be positive. At that point, f double prime will be negative because the graph of f is concave down. That's how I solve the problem. And we want to talk more about that. Anything about that that confuses you still, makes you feel uncertain in any way? Are you having a good pirate joke?
Can you explain all that again?
Yes. So are you okay that we're looking at f?
Yes.
Awesome. Are you okay that f of 1 would be 0?
Yes.
Good. So then Daniker's chart. If the f function is going up, f prime is just all the tangent slopes of f. So right here, at 1, would that tangent slope have a positive value or a negative value? Positive. So I know that I don't see the graph of f prime, but if I could see that graph, at x equal 1, there would be a point that is positive. Does that make sense? Here's a good example. The blue is f, the orange is f prime. Not a good example. Let's open up a different one. Hold on. Try this one, Kennedy. Right here, at x equal 1, the graph of f is going up, and the y-coordinate on f prime is a positive value. That's all. Does that make sense? Then we look at f, and we note that at x equal 1, the f curve has a concave down shape, which means while the f curve has a concave down shape, all the y values of f double prime will have negative values. So that's what we're saying here. Did that help? You can always say no if it doesn't. Brandon? Yes, question here. No. Which one do you want? 11.